Mark, you can hear me okay, right?
I can hear you, Deborah.
Okay, that's good. As long as someone can hear me.
Okay.
All right, thanks.
Hi, everybody. Welcome, Azure Cosmos DB Live TV, episode 45, build recap. We had build 2022 this year, and we announced a whole lot of stuff. And if you didn't have a chance to catch us at all the sessions or read our blog post or follow us on Twitter, this is your chance to check out all the cool stuff we announced this week. And so I've got with me some of my friends. I've got Gahl Levy. How are you, Gahl?
I'm doing great.
Good to see you. Deb, how are you?
Hey, Mark.
And Stephanie. Hi, Stephanie.
Hey, Mark.
Right on. So good to see you guys. It's been busy, hasn't it? As always, this time of year.
Yes.
So glad I'm going to take a nice long weekend with Memorial Weekend coming up here in the States. So very, very cool. Let's see. Where do we want to start? Gahl, let's have you talk about some of the stuff you worked on and that we released this year at Build.
Yeah, let's talk about role-based access control, which is now in public preview in the API for MongoDB. So, security is really important to us, and we want to make sure that when you have many users in your database, that we can granularity, have access control for each user, so you don't have just like all of your users having access to everything, because that's not a good idea. So this is the docs site. This feature is currently available in public preview as of build, but it's still in a gated preview phase. So you have to request access to this. We'll actually be making this available to anyone to access themselves starting in about a week. So if you're interested in trying it out, I would wait around a week to try it out. But we can go through the basic concepts of how this works and talk about this here if that works, Mark.
I see we have support for this with Azure CLI and PowerShell and ARM.
Yeah. So the same tools you already have, you're using for your management operations in general. You can keep using those for managing RBAC in your Cosmos DB API for MongoDB.
Now, can I use native Mongo tools if I want?
You use the native Mongo tools as a user to perform the user operations, such as logging in, but the actual management operations as an admin, adding permissions, to resources and roles and users are all done within the Microsoft tools, such as Azure CLI. So that way you have the same tools you use across all of your Azure products integrated into one place.
That makes sense, right? Because if you're going to be deploying and running on Azure, you should use our management tooling to do that. So, okay, that makes sense. Yep.
Yeah. So let's go over the really important parts here, and happy to answer any questions and stuff like that. But there's main concepts you need to understand when performing this kind of security operations. So the first thing is, what is a resource? So a resource is what you actually want to secure. So that's your collection or database which you want to apply access controls rules to. And the rules you can perform are actually called privileges. So privileges are what actions can be performed on your resources. For example, for collection 1, you want to only allow find commands on that collection. You could actually go like that granular. You can go very, very granular with this, or you can, be more broad if you want to. But you can really, have specific access in many, many different ways to really make sure that you're securing your database and your collections as much as possible. And that brings us to roles. So we already have, the actions you can perform on certain resources. These roles are a collection of privileges that are taken on top of a resource. So imagine you have 20 collections in your database, and one of these collections you want to share with a specific team of people, and each of these teammates will need the exact same privileges on this specific collection. Instead of having to, redo the whole thing over and over again and create these privileges for each person over and over again, you just create one role and assign that role to every single user within that team. And that way, each user in that team will inherit all of those privileges automatically. And this is kind of like off to the side of this, which I haven't mentioned this yet, but in addition to actually securing your resources as a database admin, I also want to make sure to know what each of my users are doing. A lot of times this is for compliance reasons. And with this feature, we actually basically added a column called user ID in the Mongo requests diagnostics table, which as an admin allows you to see every single operation that each user has performed. So it's much, much easier to meet those compliance requirements by just using this feature automatically. You just get those things automatically.
Yeah, that's great. I get, or I see lots of customer questions, particularly around, hey, how can I find out if somebody deleted some data or did something in there?
Yeah.
It's hard, right? Unless you have something like this. So that's great that we've thought to put this in the Mongo request diagnostic log. So
you can basically secure your data as well as see what people are doing. So it's kind of like a feature with two kind of big arcs to it as well. So that's pretty neat. I'm not going to go through every single available privilege because I can just start reading out commands and code here. But basically, privileges, you can go very, very granular here. So you can, as I said, you can assign permissions to find something, for find, for insert, remove, update, etc., and a whole bunch of others. And let's talk about a way to make this easier. So we have built-in roles. Built-in roles are a way to, as I mentioned, roles allow you to basically have many privileges that you want to have on a certain resource. Built-in roles allow you to use roles that were already created ahead of time, where you don't have to basically decide which privileges go in. So they're pretty basic, like read, write, admin, DB admin, and you can assign these built-in roles directly on top of resources and not have to do the work of defining exactly which privileges you want to have. If you're, for most users, these built-in roles will do just fine. And after that, in kind of the steps of setting up the preview, we have a clear list of steps with code examples of how to enable the preview on your account. Keep in mind, this will start working like for everyone in about a week or so. If there's an emergency you need it like by request, you can make a request, but this will be available automatically for every subscription starting towards the end of next week, maybe possibly the week after. But in about a week, this will be available to everyone, and you'll be able to basically update this preview automatically on your account and set up users, set up roles, and start using RBAC for your database account.
Yeah, very cool. And you can apply these to not just collection, but also database resources, right? So if you want to apply it across all the collections in the database, you can just apply it at the database level there.
Yeah, exactly.
Yeah, this is great. I'm sure this is something that a lot of our Mongo users want, providing that higher compatibility where they're using RBAC in their existing on-prem or VM hosted MongoDB solutions. So yeah, this is very cool. So gated right now. So you can try to sign up, and I guess we'll let you in, or you gotta.
Yeah, we'll let people in. We already have people using it, but the easiest, like the least friction way will be to wait a week, and then these steps in the documentation here will work automatically for you.
Okay.
No requests.
So you're gonna go nuts. So should we say something on Twitter next week or something so people can watch, or just keep an eye on it? So all right, folks, just watch us on Twitter at Azure Cosmos DB, and I or one of us will post a little note on there and say, "Come and get it," and you can go and sign up and start tooling around with RBAC on MongoDB API and Cosmos DB. So yeah, very cool. Anything else you want to share with us for our roundup this build?
Yeah, one last thing is we also have a preview that's ongoing right now. This one's by request. We'll be opening it up to anyone who wants to try it without requesting it. But right now it's still by request. We have a preview for increasing the current document size limit from 2 megabytes to 16 megabytes. So it just gives you more flexibility. If you want to have larger document sizes, you can with the API for MongoDB, and that's currently by request. But we'll be opening it up to more people, to everyone very soon. So.
Okay, so great. So people can go and they can sign up for that too. This is all. So where do they sign up for these things?
There's a preview features. Is a way to sign up for preview features in our documentation that kind of goes through that, and that has instructions on setting up.
Okay, sounds awesome. All right. Well, thank you very much, Gahl. And next, I wanted to bring on Estefani. And Estefani, you're going to share with us something also MongoDB related too, aren't you?
Yes, I am. Actually, what we have today is we have a new extension for Azure Data Studio, which is a desktop tool. It's a very lightweight, free tool that you can download. So how to access this is a familiar Azure portal. If you go into an account, you can then select this handy dandy button that's called Connect with ADS. So here, let me refresh this. Sorry, maybe it just was on standstill for some time. 1 second.
While you're there, I'll put up this handy little AKA AMS link that people can go and learn about ADS support. So for people who may not be familiar, Azure Data Studio is kind of our client tooling, I guess, if you can say, for kind of products in Azure Data. Like, I guess SQL DB users would be very familiar with this tool. So this is brand new. And Mongo is the first API to get support for this. Is that right?
Exactly. Yeah. So we are putting out, actually, this is the first, Cosmos DB in general is the first NoSQL database that is being onboarded onto Azure Data Studio, which is cool on its own. But specifically, we're using MongoDB API. So this is, once you click that button with Connect ADS, you can then, if you already have Azure Data Studio installed, then you can just select Connect Account with Azure Data Studio, and it pre-populates a lot of fields for you. If you don't have it, it takes you to installation instructions, how to get the insiders built and get that up and running. In this case, I already have it installed, so I'm just going to hit Connect Account with Azure Data Studio, and then it's going to open up an instance of the Azure Data Studio installed locally on my computer. I'm going to select Open to open on my account, and it should be opening up here. So on the right side, you can see like it already pre-filled a lot of properties like the account name, and then here I'm going to select to connect with AAD authentication. So when I select Connect, you can then see the connection opening up here. So here on the left side, you have a bunch of different servers. In this case would be your Cosmos DB accounts or your Mongo accounts. And then when you double click on the account name, you will see a dashboard opening up for that particular account. From here, what you see is basically a dashboard that we have built in Azure Data Studio, where you can see getting started. So you have a couple of different things here. You can create new databases. You can query data with Mongo Shell. We have some links to documentation or opening up in Portal, as well as different things like regions, consistency policy, backup policies, things like that. So if you select databases, this basically gives you a database overview of all the databases in your account. So here you can see I have a couple of different databases, my data usage, number of collections, and the throughput. And then if I select this particular collection, you can see a collection overview. So this will open up and in a second, and you can have a couple of different options here, like opening up a new collection or creating a new collection, or adding in sample data. So this import sample data button actually opens up, or actually imports about 10,000 documents into your account. So just to get started, it will be really quickly for you to get up and running. and have some sample data to work with. So yeah, this is taking a little bit longer to load. I think it's my internet connection. So
That's okay. What kind of sample data do we have available for customers to play with?
yeah, so we have a lot of like customer data. So we have things like customers, and you can see things like purchases and IIDs and a bunch of different things on there. So it's actually pretty robust data set for you to go ahead and play with. It's pretty good. I think, Mark, you have even more experience using that particular data set.
Maybe.
Potentially, perhaps.
Yeah.
So that opened up. So now you can see all of my collections and the number of the data that I have and number of documents and throughput associated with that collection. Then I can select this this is the one that I've actually opened up previously. And you can see an instance of Mongo Shell open up. So here you can actually just query the terminal, which is in this case, Mongo Shell. You can either select it through here, Mongo Shell. I actually already previously ran a query here. So in this case, I'm doing db.persons.find.pretty, which is a common query for Mongo. So if you run that, you see all of the data here that I was mentioning previously. You see your sales order. You can see what type of customer it is, the ID, name, emails, creation dates, passwords, a bunch of different details here. So it's pretty robust data set that you can get started just querying Cosmos DB and playing around with it. And then the great thing about this is that it is the Mongo shell, so you can run all the particular Mongo operations that you typically run in this particular view. And then one last thing I wanted to add is that we also heard feedback from customers on using the portal. And one of the things we saw is that you want to go back really quickly across different accounts, right? Like if you have one account or you have another account and you want to query those accounts like side by side, it was kind of difficult to do that in the Azure portal. So here I have another account open up here. And if I double click on that particular account, in a second, you will see that we open up another dashboard view. In this case, you can then open up another instance of Mongo Shell, something like this that I have here, and then you can query that account. So all of the instances will open up here, so you can quickly shift through the tabs, and it's so much easier to, if you're working with a lot of different accounts, a lot of different databases and collections, you can just quickly shift through those, and it's easily accessible there for you.
Yeah.
Yeah.
Very cool.
Mm-hmm.
Yeah. More stuff to show me?
I think that's pretty much it. But just one last thing, if you have one more, for making connections, you can browse through your subscription and you can easily access your Mongo/Cosmos DB. They're easily identifiable by this Cosmos Mongo API, and we have a handy dandy logo here for Mongo for Cosmos DB. And then you can also log in using your connection string. And then last thing is, if you don't have this extension already built in, you can select here this extension button and then select type in Mongo and then just install. That's the name of the extension.
That interface of that shell looks vaguely familiar.
Yes.
I didn't realize ADS was an extension for VS Code. That's really cool.
Yeah, it's actually a fork of VS Code. So a lot of the things that you see here look similar to VS Code, what you're already used to, which is already amazing in itself.
Yeah, very similar. When I first noticed, it was looking at the shell or the terminal outputs there,
Mm-hmm.
and I'm like, it looks like they took a page from VS Code, and then I looked to the left, and I'm like, okay, this is basically VS Code.
VS Code, yeah, definitely.
Okay.
Yeah.
So I'm like, this looks like a familiar neighborhood. I think I've been here before.
Exactly.
Question from one of our viewers here. Does ADS connection allow access to queries stored in Data Explorer? Deb, maybe this is basically available to the queries that Deb released in Cosmos Explorer container.
Actually, currently we don't support that. So if you can see on this extension view, you can see if you drill down, this is basically what we support today, just a collection overview. But definitely this could be a feature request in the future. This is preview extension, so we'll keep that in mind for future iterations of the product.
Yeah, not a bad idea. I mean, if you're using the query save tool that we've got in Data Explorer, maybe being able to share that into ADS. Yeah, that makes sense.
Yeah.
I love that you're using Mongo Shell as kind of your default query interface. That makes a lot of sense
Yeah.
in there. So yeah, this is very cool. And then just available. Let me put up the this here. So if people want to go and check out the docs on this and then how to acquire it, this VS Code extension, aka MS dash or not dash slash Cosmos dash DB dash ADS slash learn more.
Yep.
And they'll go to a friendly docs page and where you can learn more and download and connect and play. So very cool. Thank you very much.
Yeah, amazing.
Great. I love it. So one more question. So there's an extension to this that already works with SQL API?
SQL API is not supported at the moment for Cosmos DB, but regular SQL server does work on here.
Sure.
Yeah.
Okay, so for Mongo, or for Cosmos, Mongo is the very first.
Yeah, very
to get
first.
support in ADS. Okay.
Yeah.
That's I think that's surprising and very cool. I love it. I love it. So, all right. Thanks, Stephanie. And last, I can't forget about Deb. Again, just so much Elasticity updates we did for Build this year. I don't think people realize the scope of all the stuff we announced, but there you've got it on one slide there. So let's dive in, Deb, and talk about all the stuff we released or announced at Build this year.
Definitely, Mark. Yeah, like you mentioned, it's definitely probably the biggest update we've done to this space in a while since we released Autoscale a few years ago. So for customers today using serverless, we now have a preview you can sign up for where we're expanding the container size to 1 terabyte. So previously the default limit was 50 GB. So if you are a customer who has workloads that have very, very occasional traffic, benefit from the serverless model where you're only billed for the RUs you consumed, but might have larger stored workloads, you can now have up to 1 TB in a container. So feel free to sign up for that preview and we'll onboard you as soon, depending as requests come in.
Is there that link I put below? Can people find the sign up from the link from the AKMS link I put up for serverless?
Yeah, so it describes where you go. I also have a screenshot later in this deck showing visually in the portal where you can look for it.
Okay, perfect. Yep.
Cool. And for customers using provision throughput, we have a lot of updates to help you get more flexibility in the way you do partitioning, scaling, and to help you optimize your workloads for better cost and performance. So first feature we have here is hierarchical partition keys, which is now in public preview. So big thanks to everyone who signed up for our private preview and gave us feedback. We did make some changes and updates based on that feedback. This feature is now, you can use it on any account that's SQL API, so you don't have to sign up anymore. You still have to use the supported versions of the SDKs to create the containers with the keys, but it's now no more signups. The idea behind this feature is you can now partition by up to 3 levels of partition keys. So you can further subdivide or subpartition your data for a better data distribution and ultimately better query performance. So by default in Cosmos DB, there's only 1 partition key, and it can be hard to choose one that satisfies all your query as well as your storage requirements. So with up to 3 levels, you can be a bit more granular and make it such that if you have multi-tenant scenarios where a partition key value or a tenant might exceed 20 GB, or you're using synthetic keys where you get a lot of cross-partition queries because you can't partition just by, like, say, a single tenant because it's part of a synthetic key path. Partition keys, hierarchical partition keys will solve that problem. So we'll show an example later in the portal of a demo of how queries become more efficient when you partition optimally with this feature. We also have the first preview of partition merge for SQL and Mongo API accounts, assuming your accounts meets the eligibility criteria. The idea behind partition merge is that Cosmos DB can now help you optimize and reduce the number of physical partitions if your throughput or storage workload drastically changes. So for example, if you had really high throughput requirements before, say you scaled up to 1 million RUs, which is a lot of RUs. I think most workloads don't start there on day 1, but if you get there because your workload succeeds, that's really awesome. But let's say maybe you scaled up really high to do a data import and finish quickly, and now you realize you don't actually need 1 million RUs for steady state. You can now scale down your RUs while reducing the number of partitions you don't need and get better performance by ensuring there's enough RUs per partition. In the same way, if you had a lot of storage before, say you had, let's say, 3 years of data in Cosmos DB, but your business requirements change, and now you only need 3 months of data. Instead of storing all of that old data, you can TTL it out and then we can reduce the partitions afterwards, so you have more efficient storage per partition. So we'll share a sample of how you can use that as well. We also have a feature called burst capacity, also applicable. This one we have available for all APIs right now, as long as you, again, meet the preview eligibility requirements for the feature, which gives you more flexibility and taking advantage of your previous unused capacity to handle future database spikes. So today, Cosmos DB is pretty strict in its resource governance. Even if you never use your, in the provision throughput world, even if for the past hour you didn't use your RUs, or you provisioned, let's say, 1,000 RUs, but you only use 500 of them, there's no credit given for not using all of that. Right, so with burst capacity, you can now accumulate up to 5 minutes of unused or idle capacity that can be applied to future spikes. So for a temporary, short, limited amount of time, workloads that otherwise would have been throttled can be served by burst capacity. So the net effect is for physical partitions that have less than 3K RUs on them today, you can accumulate up to 5 minutes of burst capacity and burst at a rate of 3,000 RUs max. So we'll share a quick demo and show how that works as well. This is compatible with both manual and auto scale. So we'll also see how, even if you have auto scale, burst capacity can help you even further. And then finally, for workloads where you have potentially skewed workloads, because you either have a partition strategy that started out as fine or became skewed later, or maybe was never the right key in the beginning, instead of now having to migrate your container to change your partition key, you can now give physical partitions that have logical partitions that are hot more throughput than the other partitions. So this implies that instead of having all your partitions have the same amount of throughput, you can now give one different or set custom RUs per partition. This is really a power user feature. So we expect if you have a good partitioning strategy, there's really no need to play around with this needs 501 RUs, this needs 499 RUs, no need to get to that level. But if you have one consistent hot partition that hey, it looks like store ID 5 is on partition 3, and store ID is one of my 10 only stores, and it has 90% of my traffic, I'm going to try to give that partition the most throughput. If you have workloads where it's unpredictable, the hot partition, would not recommend this version of the feature for that right now, since this is a PowerShell CLI command that you need to tune kind of reactively. But again, great feature if you find yourself stuck in that situation and just need some relief and solution there.
Yeah, I agree. Saying before the show, I took a look at the docs, or just walked through the docs in there, and it is involved. There's some commands you need to run. You need to look at log analytics. You need to, at least in the monitoring and metrics stuff. So there's quite a few steps, and you definitely want to make sure you know what you're doing, and spot on if it's unpredictable, because it's not simple configuring this stuff. But when you get into kind of deep water on a hot partition, and you need some way to kind of survive that without, having to crank up the throughput across everything, which can actually cause more problems. I've seen that before, where someone's like, oh my gosh, I got a hot partition, and then they jack it up to 1 million RU, and then they're like, wait a minute, all my queries are really slow now. What happened? Right. So this would be a better option for you to ameliorate that scenario. So very cool.
Definitely.
Very cool.
Well said. I'll also add, just as a general recommendation, I think the first thing you want to do if you're running into these 429 problems, besides figuring out the root cause, is see if you have the optimal partition layout. If you have, let's say, 1 million RUs and too many unused partitions, you can merge first to get to the optimal layout, and then you can start tuning your RUs per partition or take advantage of burst capacity. Right.
That's a really great point. Look, each of these things kind of solves for a different thing, but you could use them together, and that's a great scenario. Is if you've got high fragmentation for your throughput, do a merge on there, analyze what you've got in terms of the request on there, and then apply the throughput redistribution where you think it's necessary. Yeah, very cool. I love this stuff. We do some of this is one of my most favorite areas, of course, in a scale out database, the whole elasticity and the throughput and how we manage all that. I know for some users, it's hard to wrap their heads around how to plan for this and design for it. But I love the work that we're putting into this to try to make this a smoother experience for folks. It's really, this is just great stuff. And the engineering that's going into it is really remarkable. So awesome. I got questions lined up, but I want to let you show off some stuff here. I'll save I'll save questions to the end. So folks, if you got questions, keep asking. I'm looking at them, and then we'll pop them on to Deborah here in just a few moments. So you're gonna shift gears here and show us some cool stuff.
Yeah, I'm going to switch to the browser. I also want to echo, Mark, to your point. A huge shout out to the engineering team who worked tirelessly on all these features. Some of them have been in development for years. I mean, the amount of work it takes to merge partitions while keeping your workload online, highly available, with no impact from the client side to the service side is a lot.
These are not simple engineering problems, folks. This is really complicated stuff. Not to toot our own horn, but just giving you calling it like I see it on there. So, but it's one of the reasons why I love this team is the people that work on this service are brilliant. So cool. All right, let me add you back in here, and awesome. Yeah.
Cool. All right. So the first feature I want to demo is subpartitioning or hierarchical partition keys. So this feature lets you add up to 3 levels of keys, and it's really a good scenario for when you have multi-tenant scenarios or you have workloads where you'd otherwise use synthetic keys. So let's take a look at an example here where I have a container that stores some transaction data from some customers at a store. So in this scenario, I have a store ID and I have a transaction that happened at each store. But because I know some stores have a lot more volume than others, I know that I will quickly exceed 20 GB of data on a single store. Today, the workaround many customers do on Cosmos DB is they use synthetic partition keys. So you'll use some combination of store ID and a property with high granularity. This works by letting you scale beyond 20 GB for a single store ID. But the problem is if you want to run a query, it becomes cross-partition, which becomes inefficient as your storage volume and your data size grows. So to actually show you what that looks like, we can run a query here. And if I run this query, it's going to look for store ID 2, where number of items is greater than or equal to 10. So people purchase more than 10 items. I already know when I provision this collection, I have 10 physical partitions. So because I can't provide the partition key in my query, this is going to go cross-partition. So I'll run this query. You can check the query stats in the poll to see it consumed around 34 RUs. And I actually downloaded the per partition metrics earlier today and see I'm actually hitting all 10 physical partitions to try to serve this query. Now, in contrast with subpartitioning or hierarchical partition keys, I can now partition natively by my 2 keys. So that's store ID and transaction ID here. And because you've told us that transaction ID is kind of the next level of granularity for your data, if a store ID exceeds 20 GB or the physical partition exceeds the storage limit, we can just kind of take the store data and split it further by transaction ID. So if you have a store ID that's growing very large, let's say has hundreds of GB in it, it might be on 2, 3, 4, 5 physical partitions, but it's unlikely it's going to be on like 100 partitions, right? Unlike the cross-partition query case with synthetic keys. So the store ID might be on, if you have 10 physical partitions, as the storage grows, it might be on 1 or 2 of them, and all queries will go to those targeted partitions. So we'll go here, and I will run the same query, except I will run it against this container this time. And we should expect, because now we're able to provide the value of store ID into the query, this should be a efficient single targeted partition query. So here again, query stats, this query only consumed 3.4 RUs, which is basically 10x cheaper RUs, which means for the same throughput provision, I could run 10 times the amount of queries by having a better partitioning strategy than with synthetic keys. And again, if I look at the query metrics, it's only looking at partition key, the partition key range ID, a physical partition that had that data. Now, if my store ID 2 data was very large, I could have, let's say, maybe 3 or 4 partitions was hitting. But in any case, I wouldn't have to hit all 10 partitions in my data.
That's great. And not only 10x cheaper, but faster as well, I'm guessing, if it's not having to traverse all those physical partitions. And this is great. I mean, doesn't have to be one partition, but a bounded set of partitions is definitely better than hitting all of them. So I can see how this just makes so much sense when you've got this type of either a SaaS application or something where hierarchical partitioning just makes sense in terms of how your data is structured and makes sense from your access pattern perspective.
Yep.
Cool. I can ask you, you want to take a question or two on hierarchical partitioning? I think I saw a couple in here. Okay, well, here's one. Hierarchical partition keys versus composite index. I don't think this, well, I'll let you talk to it. Yeah.
So I think they both address different problems, and they can also be used independently. In my mind, they're a bit orthogonal. So with composite index, you're basically, if you have a specific query that you need to serve, you're going to optimize for that query. Now, that query could be run against a single partition or multiple physical partitions, right? But as soon as it gets that partition, it's going to be able to be served efficiently if you have the right index there. Hierarchical partition keys is really about ensuring that if you have this kind of hierarchical data, as the first level prefix, or in this case, the tenant ID grows, the amount of data will be on a bounded set of physical partitions. So within all those physical partitions, you can still have your composite index on, let's say, transaction ID and date or something. But when you run the query to look for, let's say you want to order by date or some other property that you'd want to use in your composite index, the fact that you can only go to targeted number of partitions will save you about 2 or 3 RUs on each request. And then, of course, you'll get the composite index benefits there as well. Yep. So they're not mutually exclusive at all. They both work at the same time.
It's an and, not an or.
Yeah.
Right. So, yep. Cool. I have a question. Came across this earlier today. I can't remember where. It might have been on Twitter or something. But why stop at 3 for the hierarchy? Could we go more? Are we thinking about it? Is there? I don't know. Just asking.
Yeah. So the current limit is 3. What we found, at least in our private preview, is that for the majority of customers, 2 keys was sufficient. Typically, we found if you have a scenario where you have this hierarchy and you have a query pattern that where you can avoid cross-partitioning queries with this feature, your keys up front. So for example, if you have a multi-tenant scenario, usually tenant ID and user ID. The point of the third key is really there to, if you have a scenario where it's like a single tenant and a single user, even that exceeds 20 GB. So imagine Microsoft tenant, we've got, let's say, Mark, your data, and you have 20 GB of data for whatever reason. With the third level of key, if you pick something super granular like transaction ID or a GUID, it basically guarantees that for that third 3-part combination, it'll be impossible to have more than 20 GB for like Microsoft Mark and a random GUID. Right? So typically we'd advise for that third key, if you're worried about not having enough granularity, just have a high cardinality field in there. And it still works out where if you want to query for all the data by Microsoft and Mark, as long as you can provide both parts of that prefix, Microsoft and Mark, it'll still only go on the targeted number of partitions. So now your data for Microsoft and Mark might be on 2 or 3 partitions, but as we need to split, we'll use the transaction ID to further. I'd say
interesting. You could almost. Sorry. Go ahead. And then I want to interrupt with my random thought.
No, go ahead, please.
I'm just going to say, it almost seems like another potential scenario, and you can correct me if I'm misreading this, is the ability to solve for read heavy and write heavy. Like I could have company ID and employee ID, and like say employee ID Mark, I have an insane amount of data that I'm having to ingest, and I need to handle the ingest, the writes better. So I could potentially define what you're saying, like a GUID or something like that, to kind of spread the load on the writes across a greater set of partitions. But then on the read path, just use company ID and Mark to get the data. Is that a potential scenario, or am I overselling it?
I'd say potential scenario maybe with one caveat. So as you start writing the data today, we try to keep the data locality. So in the beginning, all the data with, let's say, Microsoft and Mark will be in the same partition. But as the data size grows, then we split and add more partitions. So if your data is, let's say, on 3 partitions, having that third level key of GUID will actually distribute evenly across all those 3 partitions, and so on. I would say from the scale of like, do you want one tenant in one container, or do you want multiple tenants in a container? I think if you have an extreme scenario where the work, like a tenant is going to be 99% or even like 75% of the workload, probably best to isolate them in their own container just for best performance, and you can control their settings more. But if you have like a lot of tenants which are Maybe some of them are still larger than others, but there's no like single huge dominant tenant. Then hierarchical partitioning keys is a great fit for that.
Got it. Okay, makes sense. So a lot of our original guidance still applies in that for that tenant isolation, where you really got massive asymmetry between requests or load volumes. Stick them in their own container, and then use this for the rest in there. So makes sense. Okay. What else?
Cool. All right, let's take a look at the next feature, which is partition merge. So this feature is currently in gated preview and supported for a limited subset of accounts, which are all publicly documented. So I won't list them all here. But as long as, I'd say the high level ones are for a SQL or Mongo API, you need to be on the right version of the SQL API SDK, which supports merge from the client side, because there's a lot of work that needs to happen there to make sure results are correct if a merge is. But let's go into a demo of how partition merge works today. Okay, I'll minimize this for now. So let's say I have another collection here called container to merge, and I provisioned it with 100,000 RUs. And with autoscale, that gives me about 10 partitions. So I'll just run to see how many partitions I have. And over the last 4 hours, I had around 10, or exactly 10, rather. So for this collection, it's possible I don't actually need 100,000 RUs forever. In fact, maybe I just did it because I ran some data load, and I actually want to scale down my RUs further. If I scale down my RUs to 10,000 RUs, this helps me save on cost, which is great, but I still have those 10 partitions lying around. Before, with 100K RUs and 10 partitions, each partition had 10,000 RUs. But now each partition only has 1,000 RUs, which is basically makes it more likely that if I have a sudden spike or if I have a change in my workload pattern, I might actually not have enough throughput. So the observation here is if I merge all my data, I can actually have a small number of partitions and ensure that each partition gets more RUs to serve the workload, which reduces the chance of getting rate limited or 429s. So the way merge will work is it's a PowerShell or CLI command in the preview Cosmos DB extension DB to merge or optimize the partition layout of your container. So the guidance is always to set your RUs as close as possible to your recommended throughput first. The only information we have your RUs and your storage, which are the key main factors in determining the layout. So we always want to make sure you have enough partitions to satisfy your RUs. So with 10,000 RUs desired, we can actually serve that with one partition. A partition holds 50 GB of data. I know I have less than 50 GB of data in here. So we can actually go ahead and take a look at the commands to do this merge. Looks like I need to reconnect. Okay, I will reconnect.
Sorry, everybody's demo is blowing up today. It's okay.
Yeah. All right. Well, I guess this is okay. Now I can actually show you the things. So first, I'm gonna set my subscription context. You can ignore this. I think we just have a lot of subscriptions internally, so it's the default one is never the right one that you want.
It's never the right one. I know.
Yeah. And then the next thing that we'll want to do is we'll need to get the preview command installed. So I'm going to go to merge. So we have a new doc here as well. Make sure you install this preview extension. And I've already enabled this account for merge, so it's been accepted into the preview. So if you don't have your account enabled for merge, this command will return an error saying your account is not enabled. So make sure that you are in the preview first, and then you can install this module. So let me paste in this command. Now, I'm not going to actually run the merge itself because it can take some amount of time depending on the data size you have and the number of partitions that need to be merged. But we do have this very handy what if flag we can pass in. That when you pass in this flag, it basically tells the command to return the output of what would it look like if you did actually merge. So Cosmos DB will not actually run the merge. So this is great because then you don't have to worry, oh no, I realized I changed my mind or I didn't set my throughput to the right value or something. You can actually run a simulation to see what that would look like. So in this particular container, I had 10 physical partitions. I think I have actually less than 1 GB of data in this container. I know. So, I mean, 10 partitions, each one can hold 50 GB, and 1 GB of data. That's way too many partitions. So we'll give some time for the simulation to finish. It's basically seeing, okay, if we were to move data in the background like this, what would the end partition layout be, and what would the storage per partition layout be? So so we'll give that some time to run since it needs to calculate all of that. But this is really great for if you just want to see what it would look like before you actually do the merge, which could take up to, depending on your data size, I'd say give it at least 5 or 6 hours. I mean, if you have like no data at all, it'll be faster. If you have terabytes and terabytes and like multiple regions of data, probably will take longer than that.
A lot of time, right? Just like backup. I would get people asking questions like, how long does backup take? And I'm like, how much data you got? I mean, it all depends on how much data is there. This has got to be this is the same rules apply here. It's not, there's no way to determine precisely. Really, you just got to let it go.
Yeah. And I'll say one note as well about this actually finished, so I'll say this, go look at this first. So this basically says that if I were to merge this collection that had 10 partitions and I guess at the time less than 1 GB of data. I've been running a data generator, so probably
like 4 megabytes, or is that 4 gig? How many? I can't read that.
This is KB, so
4
yeah,
million.
so it's around
GB.
4 GB ish.
4 GB, yeah.
Again, still can fit on one physical partition. So this just says, if I were to run this merge right now, assuming I kept this number constant and assuming my data size didn't further increase during the time of the merge, I would expect to have around, or actually not around, just one physical partition with this amount of data in it. So that means I know if I have 10,000 RUs, I've got one physical partition that has 10,000 RUs. And then once I get to that point, I could even lower it further. Right? Say I realized, oh, I actually don't even need 10,000 RUs. I could go all the way to 1,000 RUs. And then with one partition, I could easily lower down further. So really great in giving you more flexibility in changing your RUs, optimizing your layout when either your throughput or your storage requirements change.
Yeah, this is great. And really a way to kind of deal with kind of the throughput fragmentation when you do massive scale up to, that's the typical scenario that I think we all see is, I want to ingest some data. I'm super impatient, so I'm going to provision 1 million RU. I'm going to ingest that data in, and then go, oh no, I can't scale back down. And even if you do, like what you showed there, like, yeah, okay, I could go from 100,000 to 10,000, but then I've got data. Each of the physical partitions only has 1,000 RU, so I might run into problems there, which is really it's again one of these concepts that just is hard for people to kind of wrap their heads around with scale up. But this is fantastic, very cool. I like the little use of the what if feature in PowerShell there. I was exploring CLI with one of your devs the other day who was showing me this, and I'm like, I don't think there's a CLI or excuse me, a what if in CLI. And I went poking around, and sure enough, there isn't. In fact, the resource providers, there are resource providers that have what if, but they just basically fake it with their own what if parameter in there. So when we come back to doing CLI for this thing, we'll have to just what if parameter in there to kind of provide that same functionality we get with PowerShell here. So
I agree. I one thing is in the PowerShell now we have this nice what if, and there's also support for if I actually started the merge, it would ask, "Are you sure? Please confirm yes or no," just in case you don't accidentally like copy and paste, forget the flag. Maybe it's like on a new line didn't go through. Like you don't want to. But I think in CLI, I think right now it doesn't support the what if or the
it doesn't.
command. I think it's just not that like infrastructure just like is not hooked up in there. So we'll probably look at adding that later as we improve.
Any plan to do a portal for this at some point, maybe in the future, or want to keep this in the shells?
Potentially. I guess right now we have it in the shell, so we'll really see based on the feedback. I think merge is not a super mainstream scenario. Like it's not something we expect you to be doing every day or even like in the first 90 or 180 days of using Cosmos DB. It's if you have a specific scenario where your requirements really did change from the beginning. This is one merge could help.
Yeah.
I guess here you're kind of already in the portal, right? I could just run the shell here. But I agree. I know sometimes it's nice to have like a button that just says "do this."
Yeah, I just yeah, people like pointing and clicking at stuff, right? So I don't know.
Yeah.
All right, this is cool.
Take that feedback.
Yeah.
All right. So I think we have 2 more features to go through.
Yep.
So the next one is a feature called burst capacity. So we just showed how you can optimize your physical partition layout, but there still might be times where you still, even after you've optimized your layout, you still have spikes of traffic where you just temporarily need more throughput than you've actually provisioned. So the way to avoid having those requests be rate limited is you can use this new feature called burst capacity. Burst capacity applies for all APIs as long as you're, again, meeting the eligibility requirements described in that doc. And it basically says for any container or any physical partition, actually, that has less than 3,000 RUs of throughput provisioned on it, you can accumulate up to 5 minutes of unused or idle capacity to use for future spikes. So this is compatible with both manual and auto scale. So you can see here I've run a data generator for about an hour or so yesterday, and I have my burst capacity enabled at the account. So currently it is an account level feature. If you sign up for the preview and we enable it on your account, it'll apply to all resources automatically in the account that have physical partitions with less than 3K RUs of throughput. So as running this workload, I actually have auto scale provision with 1,000 RUs max. So this scales between 100 to 1,000 RUs. This is our entry point for auto scale. And I set the data generator, so I wasn't really using the full 1,000 RUs all the time. In fact, most of the time I was averaging around 500 to 600 RUs per second. So this delta here is really idle capacity or unused capacity. So it looks like it stopped. Okay, still working? Okay, cool. Marcus, is that a screen share okay?
Yep, it's working.
Okay,
You're a little choppy today, but other than that, that's okay.
Okay, we'll get through.
Yep.
So with burst capacity, you can accumulate up to a rolling window of 5 minutes or 300 seconds of capacity that you can use for future spikes. So in this case, I set my workload so that I would really up the amount of requests I was pushing. And I can see that for a limited amount of time, I was actually able to use more RUs than I provisioned, even with auto scale. So once the burst capacity ran out, then of course I'm going back to my normal workload. And eventually, if I was at this level of request volume for a very long time and used up all my burst capacity, then I eventually get throttled. So it's not like an infinite amount of capacity where you can always be scaling above your provision throughput. But for if you have a temporary spike, it's hard to predict and you haven't been really utilizing all your capacity in the last 5 minutes, this is definitely like a nice flexibility, like almost like safety bucket to draw RUs from.
Yeah, I love it. So the limit is, what's the max throughput you can have and take advantage of this?
So the max RUs that a single partition can burst to is 3,000 RUs. So This basically means if you have a physical partition with more than 3,000 RUs on it, you're already getting pretty high burstability, right? If you have 10K RUs on a physical partition, if you have a spike, you can get up to 10K RUs, right? So this is really for physical partitions that for whatever reason don't have that much throughput on it. Less than 3,000 RUs and may have can now just have more flexibility in how often, how much they can spike up to.
Okay. Very cool. And then last, what have we got? Throughput distribution. Yeah,
so this one I will actually go back to the PowerPoint slide because I think it's a bit easier to share with the visual there. And we'll eventually add the visual to the docs since I think the docs are probably a bit abstract right now, but we'll improve them over time. So let me share the PowerPoint now.
Maybe I can ask you some questions while you're clicking away there. Here we go. From Hassan, do you have any plans to add different ways to execute partition merge and throughput redistribution? It looks like, this is the question I asked earlier. Looks like the only way to run these features is PowerShell way for now. So, Go ahead.
Yeah, so for merge, we actually have both PowerShell and CLI. Those are both available today in the preview Cosmos DB extensions. For throughput redistribution, we have PowerShell published right now, and we're working on getting the CLI published in the next week or so as well. So we will have support for PowerShell and CLI. Be curious to hear what other ways you're interested in. I know Portal is probably one interface. If there's any others, please let us know your feedback.
Yep. Okay, let's add you back here. Gotcha. Okay.
All right. So this last feature gives you the ability to essentially set custom or different RUs per physical partition. The main scenario for this is if you have a consistent, predictable hot partition that you know will always be that hot partition, and you're actually seeing a negative impact by seeing current throttles today. If both of these are true, then it might be time to give that partition some more throughput. So this basically makes it so that you don't have to necessarily provision for the hottest partition. If you have one partition that's really hot and you need a 10K of throughput, it doesn't mean you have to actually provision 10K times number of partitions to give everyone 10K when only one partition really needs it. Throughput to partitions that need it most. All right, so again, just want to reiterate, this is a pretty power user feature. If you don't have any throttling today, or if you have between a manageable 1 to 5% request of 429 spin collection and your end-to-end latency is okay, we always give the guidance that it's normal to see some level of throttles in Cosmos DB. It just means you're using the system efficiently. If you didn't see any throttles, which means if you never try to exceed your provision throughput, then you might be a little over provisioned, right?
That's all right. I get a bigger bonus. That's okay.
Yeah, so seeing 429s in and by itself is not a reason to panic. The client SDKs, the libraries, they all retry up to 9 times. So sometimes the service might say you reported a 429, but your application may never have even seen it. So if your overall percent, which you can measure in the Azure Monitor metrics, and your overall end-to-end latency is okay, then you probably don't need to worry about the 429s or 2 in the future. I mean, you can always continue to optimize, so that never hurts you, but it's not like as dire as initially seeing those 421s may lead you to believe.
Yep.
That said, there are very real scenarios where you might be in a situation where you do have a consistent hot partition. So for example, in that store data I showed, suppose store 1, which we can find in log analytics is on partition 5, became a really hot store, and all the other ones just had very average or low usage. Right, we want to give that physical partition more throughput so it can efficiently process transactions and requests coming from directed to that logical partition. So let's take an example just visually to get a sense of how this API works. So you will do this via either PowerShell, and CLI is coming as well. Let's take a basic example where we've got 3 physical partitions and 6,000 RUs of throughput. So this can happen if, let's say, I started with 30,000 RUs of autoscale throughput and then scaled it back down to 6K. Right? Let's say you identified, this is a typo, let's just say partition 1. Okay, this is partition 1. Suppose we identified that partition 1, this orange one here, is the consistent permanent hot partition that we want to give more throughput to. So currently, every partition has 2,000 RUs, which means that it's likely this one is getting rate limited, and these, if they're less quiet, might not be fully utilized. All right. So the observation is we want to give 2,000 RUs of throughput to the hottest partition. So the total will be 4K RUs, and then we'll just take 1,000 RUs from each of the other partitions. So sorry, this should say 1,000 RUs. Okay. So basically, at the end of after we do the command, we'll have one partition with 4,000 RUs and 2 with 1,000 RUs each. The concepts that we have for this API are there's a concept of a source and a target partition. So the source partition are the partitions that you're basically borrowing or redistributing. Maybe taking is probably a better word since you're basically redistributing the throughput and giving it to the partition. And the target are the partitions that you actually want to give them more throughput. So our hot partition would be our target, and the sources would be the other partitions that we want to borrow from. You can change up to 20 of these in one request, but typically I recommend try to just change 1 or a few. If you try to do too many at once, it might get confusing to rationalize about all of them. And the good news is you can specify the level of throughput that you want Cosmos DB to maintain on each partition. So we're basically saying here, partitions 2 and 3, I want them to have 1,000 RUs. Cosmos DB should maintain that. For this one, I should have 4,000 RUs. It still adds up to 6,000 RUs, which is my total throughput. And I just run this command in PowerShell. We also have one from Mongo as well. Update the container per partition throughput. So this will run. It takes around the same amount of time it takes for you to like change your total throughput. And once you've done that, then it'll be reflected. And ideally, you would then see fewer 429s going on your hot partition. Very
cool. I have a question. I've got some from our viewers too, but ask a question. Let's just say I do this, what you're showing me right here. What if I go back into the portal or wherever and I change the throughput? What happens?
Yeah. So when you change the throughput, so if you scale your throughput down, then proportionally everyone has the same amount of the new RUs. So if you had 6,000 RUs total and you went down to 3K, it would be like 500, 500, 2,000. So those throughput fractions get respected.
I see. So it applies a proportional share behind the scenes with the whole number of throughput values that you input using this.
Right. And if you scale up, it can get a bit more complicated. So the recommendation we typically give is if you're scaling up, and scaling up causes one of your partitions to like think that it should get more than 10K, but it can never get more than 10K. We have a command to actually redistribute and reset everything to equal. So if you realize, oh, I made a mistake or just want to reset, instead of use the same command, but instead of passing in source and targets, there's like a flag that's like equal distribution policy. So I recommend if you're scaling up and especially if that changes the partition layout, say you went from say 10,000 RUs with one partition to 100,000 RUs with 10 partitions, or maybe like 2 partitions, right? Your data could be on a different physical partition. The thing that was hot before might not be hot anymore, right? So it's worth always evenly setting it to even distribution again, monitoring to see if you even still need to give more throughput. Right, if you're giving more throughput overall, by definition, the hot partition has more throughput. So do you even need to give it more than that? Right, so just set it to equal and then monitor it. And then if you don't need to, then you can just leave it, but you can tune it again if you want.
Okay, that makes sense. Very cool. Got some questions from some of our viewers here. This feels like a short-term Band-Aid while we fix the data model for proper partitioning. Is that accurate? Or is this okay to run in the long term?
I would, I guess that's probably maybe like a more stronger way to restate the guidance. I think it definitely is I think like it does provide that short-term relief, that Band-Aid for if you have, like if you're really in a situation where the partition key is not optimal, then often revisiting your data model or changing the partition strategy could be the right thing, right? So that said, I mean, it will work, right? If you say you want to partition to 4,000, have 4,000 RUs, you never touch it, your workload stays the same forever, then it'll keep working. I think the guidance is it's hard to think unless you can really predict which partitions will be hot in the future. I wouldn't necessarily try to. I mean, you could, right? You could programmatically try to tease this out and keep updating it. But I think for that, probably revisiting your partitioning strategy would be the most long-term sustainable solution.
Yep, makes sense. Last question, unless somebody pops one in before we close out here. Can Cosmos handle the merge automatically? That's something we're looking at in the future, maybe?
Yeah, that's something that we, definitely in the future. It's going to be a while out. Right now, it is all controlled by the user. One of the reasons for that today is, at least for SQL API, in order to guarantee correctness for your queries and feed operations when a merge is happening, you have to be on the right merge proof or merge supported SDK. So in the same way that all of our SDKs handle when you split partitions, we have to handle merge as well. So we would never want to, automatically merge merge collections for an application that wasn't using the updated SDK and then have a correctness issue, right? So really it'll be based on I guess probably when the ecosystem catches up, which is actually a call to action for everyone watching. If you're on SQL API and you're using the .NET SDK, get to V3 and then get to version 3.27.0 or higher. That is the earliest version of the merge-proof SDK. We published that, I think, a week and a half ago. So that is a requirement to be in the preview because your requests from older SDKs will just not work. So
Yep.
I think we are eventually deprecating. I help folks find how to sign up. So I think this is the same place that Gahl was referencing for how to sign up for the Mongo related features. In the Azure portal, if you go to your subscriptions overview page, so not your Cosmos DB account, but your subscription overview page, go to the preview features section, and you'll see there's a bunch of pre-release features you can filter to this document DB extension and see all of them here. So these are all the 4 of the 5 features that we talked about today. You can hit click on the feature and submit a request to register. Once you submit the request, it'll have your associated email and subscription. Our team will review those requests, start checking the eligibility to make sure that everything, like the SDK requirements, etc., are all met. Get back to you via email to let you know if one of the requirements hasn't met. We'll let you know which one and see if you can take some action on it. If everything's good to go, then we'll ask you which accounts you want to enable the feature on. So since all these features are in preview, we'd recommend try them on a test account first. We have merged people in production, but I think it's always good as a principle to start in a test account, try it out first. So we'll ask you for the accounts that you want to work on, and then you can all the PowerShell, CLI, etc. will work. For hierarchical partitioning keys and subpartitioning, it's already available in all SQL API accounts, so you don't have to sign up. If you just if you use the latest SDK that supports that feature and create a container with hierarchical partition keys, then that'll just work.
Very cool. And just want to reiterate how important it is that you have all of your connecting clients running V3 3.27, I think you said?
Yeah.
Okay. So get there and upgrade. We've had V3 out there for like 4 years. It's been a while. Come on, folks, upgrade. Come on. What are you doing this weekend? You got a long weekend. Now is your chance. You can do it. Nobody's going to be working. Nobody's going to be hitting your app. So get in there and upgrade that thing. So many cool things in V3. You got to take advantage. There's transactional batch. There's bulk. All kinds of performance enhancements. Lots of great stuff. And now, come on. Now we've got another one for you. We keep throwing these carrots out. Get up there and upgrade and stay there. So, all right. This has been awesome. I knew this was going to go long. It's an episode. Just so much cool stuff that we released at Build and Ignite. And again, this year, just more stuff. Really excited about all the stuff we're doing around Mongo. We just seem like we've got kind of a never-ending stream of good stuff coming out there. And then great stuff on the desktop with our ADS support for MongoDB. Which is just mind-blowing. I love it that we're out there with Mongo support first for that. And then just this, crazy, huge amount of features around all of our elasticity and scaling throughput features here. Just amazing, making Cosmos smoother, better, more scalable database for you all. So thanks again, Deb, and thank you, Estefani. Gahl had to sneak out a little bit earlier there. So what I call it? It's the Irish goodbye. That's right. Where you kind of sneak out of the party and don't say goodbye.
Yeah.
I love it. So, all right. Hey, folks. So next week, we're back almost weekly now. We've got lots of new episodes. Next week, I've got Abhinav Ramesh coming back. He's been on the show quite a number of times. And he's going to talk about some new stuff we're doing over in our HA, so kind of our replication and failover areas there, our BCDR functionality. We're going to talk about configuring and managing failover in Azure Cosmos DB, right? So Cosmos is a distributed NoSQL database. We're available in every region in Azure, and we provide this seamless replication capability and the ability to do failover. I mean, that's how we provide the 5 nines of availability, is the fact that you can deploy us into multiple regions and have availability to your database. So next week we'll talk about that. So be sure to join us. This is episode number 46. Oh, sorry. I always throw that one up. It's the wrong one. We've got 44 other episodes you can go and check out right now on YouTube. So come and find us on AKAMS/CosmosDB Live TV and check those out. We've also got a user group growing every month. We're doing monthly meetups with new topics in there. So come and join us up on meetup.com. Link is right there on the screen. And sign up and check out our monthly meetups there. So we'd love to have you. Do a little giveaway every month for one of these very handsome little drink coasters right here. And also limited supply of these stickers left. I'll get that even closer. Is that working? Okay. So come and get them while they're hot, folks. We're not fully back into in-person conferences, obviously, yet, where you can come and get all the swag you want by just walking around the expo floor. You got to come to things like our user group, and we'll give them out to you there. So that's it, folks. Oh, maybe you got a couple of questions here. Just some thank yous. Nope, just some thank yous and goodbyes in here. So great stuff. And Goose giving us the threads up there. All right, or the thumbs up. So right on. Okay, folks. Thank you very much, Estefani. Thank you very much, Deborah. And we'll see you guys all next week, hopefully. Take care, everyone.
Sounds good. Thank you.
Bye-bye.